Warning, the video you're about to watch contains mathematics at the level of college algebra and trigonometry. All material has an assumed prerequisite of both Algebra 1, which is elementary algebra, and Algebra 2, which is intermediate algebra. While some prerequisite topics are reviewed briefly, a more thorough review of these entrance topics can be found by searching the web.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes.
Hello, my name is Roy Simpson, professor of mathematics at Cosumnes River College in Sacramento, California. In this video, we're going to continue our discussion about ellipses, and we'll continue by graphing ellipses. In the next video, we'll actually go through and build equations for ellipses given information, but this one we're going to start just with graphing here. And I'll try to include as much of the information that we've had in the initial video, which was all the definitions. So in this case, we're asked to find the center, the foci, the eccentricity, the vertices of this ellipse, and then to graph it. All right, so the first thing you need to do actually with a problem like this is get it into a standard form where the right-hand side is 1. So to do that, we're going to divide both sides by 8. And dividing both sides by 8, you get y squared over 2 plus x squared over 8 is equal to 1. Now, going along with how I like to write things, because it's just a habit of mine, I like to write this in alphabetical order. Not that you have to, it doesn't actually do anything for us, but I personally like to have it in this order here. So I'm going to do that. You should note, since there is no shift going on x and y, then our center is at 0, 0. In other words, remember the standard form for the equation of ellipse is x minus h quantity squared over the vertex for x squared, vertex distance for x squared, plus y minus k squared over the distance from the center to the vertex in the y direction squared is equal to 1. Well, in this case, h and k are 0. In this case, I should say. And so therefore our center is at 0, 0. I'll write that in. Center is going to be at 0, 0. Now, v sub x. Well, v sub x, that's the distance to the vertex in the x direction, is going to be the square root of 8. That's the distance from the center to the vertex in the x direction. That's why I use v sub x. All authors will write that as a squared or possibly b squared, depending on their mood. But this is 2 root 2. And then the distance in the y direction to the vertex is going to be the square root of the denominator of y squared, technically, which is the square root of 2. Okay, so this will help us find our vertices, right? So the I will call them major and minor vertices. So the major vertices, those are the ones of the larger group. They're the numbers that are larger, the distances that are larger. Well, between 2 root 2 and square root of 2, 2 root 2 is obviously larger. So our major vertices are in the x direction. They're 2 root 2 units away from the center. Now, often I find that when you get to this step right here, it's much easier to grab a ruler or something like that and to just start graphing immediately. So I'll go ahead and draw in the y-axis, and I'll draw in an x-axis here and get that going. And then I'll label this x, label that y. We know that our center is at 0, 0. Our vertices in the x direction are 2 root 2 units away from that center. So I'm going to go ahead and just measure out 2 root 2. I'll just say that this distance right here is 2 root 2. So it's 2 root 2 in that direction and same distance in the other direction. So 2 2 root 2 in the other direction. Let me label those points. So the vertex here is 2 square root of 2 comma 0. And in the other direction, it is a negative 2 root 2 comma 0. Now let's then, so let me write those in just so that I have those also listed here. It's plus or minus 2 root 2 comma 0. The minor vertices, write that in, vertices, those exist a distance of root 2 away from the center. And it's a root 2 away from the center because that's the smaller of the two distances of v sub x and v sub y. So that would be the minor vertex distance. So I'm going to measure that out as well. Let's go ahead and zoom in so I can, and let me get the right color here. Boom and boom. Okay, so this will be square root of 2. Get that out of the way. So 0 comma root 2 and 0 comma negative root 2. And again, I'll just write those down here for the minor vertices. They are at 0 comma plus or minus root 2. All of this stuff is pretty fast when you're used to this. It also says find the foci. So remember, the formula for the foci for an ellipse is going to be c squared times the absolute value of a squared minus b squared. The easiest way to remember that is if this is a plus, it's going to be c squared is equal to the absolute value of a squared minus b squared. If that was a minus there, then it would be c squared is equal to a squared plus b squared. All right, so let's go ahead. And by the way, a in this case is the denominator, the square root of the denominator of x, and b is the square root of the denominator of y. So this is using the notation that most authors will use. If it were me, I would be writing it this way: v sub x squared minus v sub y squared. That's really how I would normally write it if I was teaching it in a classroom. So let's see, this is going to be the distance between those two squared. So that's going to be technically just a difference between those denominators. So 8 minus 2, which is 6. And then remember, that's what c squared is. So that implies that c is equal to plus or minus root 6. Remember, c is the distance from the center to the foci along the major axis, and the major axis is the axis with the largest distance away from the center in the vertex. So the major axis here is horizontal, and I'm going to plot a point at root 6 units away from the center. Now, I'm not really measuring out very well what root 6 versus root 2 is, but I will just pretend. So I plotted 2 points there. I'm going to call this point root 6 comma 0, and I'll call this other point a negative root 6 comma 0. Let's see what else we need here. Find the center, did that. Find the foci, did that. The vertices, did that. The eccentricity. The eccentricity is going to be, let me write this here, the ratio of c to the distance of the semi-major axis. And when I say distance of the semi-major axis, it really just means what is the larger of v sub x or v sub y. In other words, take a look at the denominators in your ellipse here. The larger of them, you'll take the square root of, and that will be the denominator of this. So this is going to be v sub x. So let's see, the c is root 6, and v sub x is 2 root 2. You could technically multiply top and bottom by the square root of 2, and you would get root 12 over 4. And that would be, let's see, 2 root 3 over 4 or root 3 over 2. There you go. So that is the eccentricity, root 3 over 2. And that the eccentricity tells us how oblong this ellipse is. We'll kind of talk about that in a future discussion. And from this point forward, we just kind of graph it out. I can turn off my ruler. Let me make sure that I'm not asking anything else. Nope. So let's go ahead and scratch this out. I'll keep with black. No, I'll do blue here. Okay. And I tend to take my time graphing because it is very easy to get a sloppy graph, and I'm always sad when I see students' graphs that are really terrible, because I spend a significant amount of time graphing and all that stuff. So I'd like my students to have good graphs here. So you lead by example, right? There we go. That's a pretty decent graph, except that I totally missed, and I'm saying lead by example, so don't take that example, because it was supposed to go over here. That was close. That was a very close call. I'd be very sad if I had uploaded this video with that having survived. Every once in a while that does happen. Just letting you know. Some little mistake that I make. Forgivable. We're all human. All right. So that is the graph of that ellipse. Very nice. I guess I could talk about the eccentricity a little bit right now. Remember, the eccentricity is the ratio of, in this case, this distance right. Oops, didn't mean to erase that axis. It's the ratio of this distance right here, which we called C, to this distance right here, which we called V sub x, the vertex in the x direction. For example, in this graph right here, you have this ellipse. It's not centered at 0, 0. I just quickly looked for something on Desmos that kind of would fit my needs, but it's actually computing the eccentricity. Now remember, the eccentricity is the distance from the center, and the center is just right about here. It's the distance from the center to this foci, which is right here, divided by the distance from the center to the major, one of the major vertices, that guy right there. Okay, and so as if we start getting that distance, that ratio, to be close to 1, in other words, those distances get closer and closer to one another, the ellipse becomes more and more oblong. It becomes flatter and flatter, or as we would say, more eccentric. So this is a highly eccentric ellipse. The further away, so the smaller the distance, the ratio is. Remember, the ratio is the distance between the center to C. So this is a small distance from center to C divided by the distance from the center to the edge. The center to the edge is constant, but the center to C here is getting smaller and smaller. And so because of that, we get a circle. So as that eccentricity approaches 0, 0 eccentricity is actually just a circle. Whereas something eccentricity closer to 1 gets a very highly elliptical shape. Now let's do all that stuff all over again for an ellipse in what we call general form. In other words, somebody hands us an equation, but it's not in parenthetical form. It's not in the quantity x minus h over a squared, that type of thing. It's not in a factored form. So how would you deal with this? Well, we have skills leading up to this moment, and one of those skills, one of those math skills, is called completing the square, and that's exactly what you're going to have to do to get this into standard form. We're going to collect all terms with x's together, so x squared, that's the only term with x's, and all terms with y's together, 3y squared minus 12y, and then all constants will move to the other side, equals a -9. And now we're going to go ahead and complete the square for y, because there's 2 terms involving y. I'd like to get that to be a single term involving y. So let's see, the x squared is just going to hang out for a while. The y terms, I'm going to factor a 3 out, and I'm left with y squared minus 4y. We'll leave some space there, and then equals a -9. Now, right now, how this is written, we haven't actually changed anything. We've just factored a 3 out of those 2 terms that have y with them. But now what I'm going to do is complete the square. You're going to add into this parenthesis half of -4 squared. That's what you're going to do. Take this guy, halve it, and square it. So half of -4 is a -2, and you're going to square that. Now, I always write that minus sign there, even though I know when you square -2, it becomes a +4. I still write that -2 there for a very specific reason. That green ink was not here originally. So we're adding something to the left-hand side, and an equation is like a teeter-totter or a seesaw. If you add something to one side, it's going to basically overweight that side and you won't be in balance. So you have to add that same thing to the other side. Well, some people here would say, okay, let me add -2 squared to the other side, but you'd be incorrect if you said I'm going to add -2 squared to the other side, because you didn't just add a -2 squared to the left-hand side. You added 3 times it. So you have to add 3 times -2 squared to the right-hand side as well. Be very aware of that. Now let's go ahead and finish this out. This is x squared plus, let's see, we have 3 times the quantity. This will now factor, this trinomial will now factor to y minus 2 and quantity squared. That's just how completing the square works. And then on the right hand side, you have a -9 plus 12. And we now have x squared plus 3y minus 2 quantity squared is equal to 3. Divide both sides by 3, and you will get x squared over 3 plus y minus 2 squared is equal to 1. That y minus 2 squared, well, that's actually y minus 2 squared over 1. And now I can go ahead and start stating all the important details about the graph of this ellipse. I know it's an ellipse because it's a sum of squares, but they don't have the same coefficient. If they had the same coefficient, then I know it's a circle, but this will be an ellipse. The center is going to be at x equals 0, y equals 2. Again, it's x minus 0, y minus 2 in the formula, so the center is at 0, 2. And the major vertex, or the major axis, is the x-axis or a horizontal axis, because the larger of those two denominators is below the x. So I know the major axis is the vertical or the horizontal axis. The distance to the vertex in the x direction is going to be the square root of that denominator of x. The distance to the vertex in the y direction is going to be the square root of the denominator underneath y. There we go. And then c is going to be the absolute value of the distance to the vertex in the x direction squared minus the distance to the vertex in the y direction squared. Oops, and that's the absolute value. Well, that's just going to be 3 minus 1, or 2, and that was supposed to be c squared. So c is equal to plus or minus root 2. And then I can also say the eccentricity here. The eccentricity is going to be the value of c, which is actually technically a positive root 2. I'll just write that. C is positive root 2, just so that you don't get confused by that. Divided by the length of the semi-major axis, basically v sub x. The larger of v sub I or v sub x. So that's going to be root 2 over root 3. And you could call that root 6 over 3. I don't care. It's not. You don't have to actually rationalize denominators here. It's not going to be very helpful. And now I will go ahead and start graphing. I could have started graphing earlier. I'm just going to start graphing now. So let's see. Here's my y-axis. My x-axis is right here. Let me zoom down or go down a little bit. And let's see. Our center is at 0, 2. 0, 2. Let me go ahead and just say that's 2. And then the distance in the horizontal direction to the vertex, to the x vertex is root 3. So we're going to go root 3 units to the right and to the left. Square root of 3 is a little bit greater than 1. So I'm just going to go ahead and do this. If that was 2, then it's probably something like this. So I'm sort of creating this somewhat small, honestly. So those are our vertices in the x direction. It's root 3, 2 and negative root 3, 2. Again, I'm drawing this kind of small by accident, but oh well. And let's see, in the y direction, the vertices are a distance of 1. And again, that would be like here and here. So that'd be 0, 1 and 0, 3. I could technically at this point immediately start graphing. I don't really need to have my foci in there yet. Try not to run into my numbering schemes. And then, there we go, that's good. And then now I'll plot the foci. And the foci are root 2 units away from the center. And that would be something like maybe here. Something like that. And that is actually the full graph and the eccentricity and all that fun stuff for the given ellipse. Sorry that I didn't have one doing anything vertically, but they're all the same stuff over and over again. So it's not really any different if you have something that's more oblong in the vertical direction.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way, cause affects more than we can sometimes see. Things for what they are and work together until you feel at peace. Just listen close, don't talk too much that isn't kosher. You may really hurt inside. It doesn't justify you to speak too loud and cry.